In this video, we discussed eliminating a 0/0 indeterminate form, which happens to be what's called a complex fraction. That's just a fraction that's got fractions within fractions. Got fractions in the numerator, fractions in the denominator. If I try to substitute x equals 3 into this function, I have 3 minus 1 here, which is 2. So we end up with a 1/2 minus 1/2, which is 0 in the numerator and a 0 in the denominator. So that's 0/0. To get rid of the 0/0 indeterminate form, we're going to multiply by what's called the least common denominator of all of the denominators in this problem. So we've got in the smaller fractions. This fraction has a denominator of x minus 1. This one has a denominator of 2, and there's an implied 1 there. So we're just going to multiply the numerator of this larger fraction and the denominator of this larger fraction by 2 times x minus 1 to clear the complex fractions. So we're going to take all of that and multiply by 2 times x minus 1, and all of that and multiply by 2 times x minus 1. And if you distribute there and there, this is what you get. The x minus 1's reduce, and the 2's reduce. And so we've got a 2 here minus the quantity x minus 1. And we're dividing all of that by 2 times x minus 1 times x minus 3. If I substitute in x equals 3 now, I still have a 3 minus 1, which is 2, 2 minus 2, which is 0. So I still have a 0/0 indeterminate form. But if I simplify, I might be able to get rid of that 0/0 indeterminate form. So we're going to distribute the negative. So that negative x, or negative 1 times x, can give us a negative x. Negative 1 times negative 1 is positive 1. So that denominator was x minus 1 times x minus 3. So here in the numerator, I now have 3 minus x divided by 2 times x minus 1 over x minus 3. And I notice that this looks very similar to this x minus 3, but it's got an extra factor of negative 1 in it. If I factor out a negative 1, negative 1 times x is negative x, and negative 1 times negative 3 is that positive 3. And now the common factor of x minus 3 reduces. So we have this function, and we say, is that function continuous at x equals 3? If we substitute in x equals 3, we've got negative 1 over 2 times 3 minus 1, or negative 1/4. So the function is undefined at x equals 3, but it has a finite limit. So x equals 3, y equals 1/4. Is an open point on the graph. So let's graph that and confirm our answer geometrically. Okay, so this is what the graph looks like. And we want to graph the point x equals 3, y equals 1/4. Oops, y equals negative 1/4. There it is. And that is actually on the graph. And so the limiting value is exactly what we expect it to be. That function has a vertical asymptote at x equals 1. We see that as well. And that's what it happens to look like.